Hello, I am Ayhan Agaev, and now I'm going to show how to create tangent plane and normal line of an equation with the help of Geogebra.org. The first equation is my original equation, and first we should find the coordinate z from here, from this equation, and then we get this formula for z coordinates, and after finding this we should find derivatives of z with respect to x and y. So how we are going to do it, we will use implicit differentiation, and we kind of get this formula like this, and from here we find the derivative of z with respect to x, and it's equal to this equation, and we can see from the original equation that the derivative of z with respect to x and y are the same. The just variables are different. So this is the variable of z with respect to y. And the last thing that we should find from the equation is that the formula of z, the tangent plane, formula of tangent plane. And here, this is our formula, and here we have u. U is like, we found z, but there were two of them. One of them is with plus and one of them is with minus. So I called the equation with plus u and the equation with minus v. So here is u represents this z. So let's get to the GeoGebra part. Here, this is my original equation, and as you can see, this is a graph of it. And this is the variables in my original equation, and we can actually change the shape of this figure by just dragging this and changing the results of this values of these variables. So yes, so what we do first, we define one point, let's call it A, and it's on the xy plane, and we call the coordinates of it k and s, and then we add two formulas. Both of them are for z. I mean, we will add two more points, b and c points, and these formulas will be the z coordinates of that points. So this is the formulas of z that we found earlier. Then we assign u and v. They are equal to, as I said before, one is minus and one is plus. This formula with the arguments k and s, and this formula with arguments k and s. So u and v represents the z coordinates, and if we implement it to the a point, we get b and c points, which are the points that they are like same with the a point. I mean, the x and y coordinates are the same. The difference is we assign z coordinates for each of them, and they are both in this shape, on this shape. So what we did next, after we found our points, we have to find our tangent plane, and that tangent plane, the formula of tangent plane was this. So we just copy and paste it here. I just added to GeoGebra, and then here is k and s are actually x0 and y0, x and y0. I just replaced them with the K and S, and they represent the K and S actually, but I just named them differently. So this is the tangent plane. As we have 2 points, so we will have 2 tangent lines. Yes, one in the first one I used U, and in the second one I used V. That's why I have 2 different tangent planes. And at last, these 2 normal lines of this points, and simply we just go to tools, we select the planes, no lines, yeah, perpendicular line, and for it we just need to choose the one point and the plane that we want our line to be perpendicular to it. So for example, if we want to create this plane, I will choose B and this plane, and it will just create this line. So that was all. Thank you for watching.